In the next few videos, we're going to discuss special cases of constant acceleration, and we're going to derive a few equations that you will use throughout the semester and memorize using essentially just the few equations that we've learned already. Okay, so this is a motion diagram that shows a special case of constant acceleration. So if I'm here and I'm on top of a cliff, and I drop a ball off that cliff. We've already looked at the motion diagram for this. You can see that the ball falls, a little bit in the first second, and then more in the second, and then more in the third, and then more in the fourth. And instead of labeling these displacement vectors, I've actually labeled them velocity vectors. Since this is 1 second at each time interval, the displacement is actually equal to the velocity in this case. Okay? Now, because the object's velocity is increasing over time, we know that there's some sort of acceleration. So if we look over here, I have redrawn the velocity vectors. Okay, I've just moved them over here so we can see the change in velocity. So here's the first velocity vector and the second velocity vector, and you can see that this smaller arrow represents the change in velocity, which we know that the change in velocity over some unit time is acceleration. So that's actually an acceleration vector. And then here for the second, again, another acceleration vector and another acceleration vector. So we see that this is constant acceleration. We have the same change in velocity in every second. And in the case of something dropping, okay, what is causing the acceleration is gravity. So it's acceleration due to gravity, which is our most common example of constant acceleration, although we can also have constant acceleration in other examples, horizontal motion and things like that. So gravity, we'll need to know for the rest of the year, is equivalent to negative 10 meters per second squared. Now, it's actually 9.8, but we round it off to 10 just to make the math easier, and actually on the AP exam, they let you use 10 because you can't use calculators for part of the exam, and we can easily use 10 when we do our math. Okay, so the negative indicates the direction. Remember, acceleration is a vector because velocity is a vector. So in this case, the sign, the negative, indicates that gravity is down. Okay, so in the remainder of this video, we're going to look at cases where gravity is occurring and make some predictions. And then the next video will derive some equations in order to do calculations given those predictions. Okay, so the scenarios that I'm going to give you are two scenarios. One where I am dropping a ball off the cliff, and another where I am throwing a ball up and off of a cliff. Okay, we're going to ignore any horizontal motion. Okay, so we're only going to be talking about the up and down, the vertical motion here. We'll just pretend that this flies straight up and goes down and doesn't go this direction at all. Okay, so you can see my motion diagrams. I'm accelerating here, and as it flies up, it slows down, and then it speeds back up. So we're going to use our intuition to answer just some basic questions, and then we will go ahead and do some math in order to explain these. Okay, so the first one is, which one in which of these scenarios does it take longer to hit the ground? Okay. So in this scenario, it drops straight down, where this one, it has to take the time to go up, slow down, come to a stop, and then speed back up and hit the ground. So we should know, just using common sense, that actually the throw is going to take longer to hit the ground or spend more time in the air. Okay. Now the next question is, which is traveling faster when it hits the ground? Okay. So if we think about it, this falls from here to here. This gets to fly up in the air and then fall a further distance. So we would predict that because this has a farther distance to fall and more time to accelerate and speed up, that it then would be going faster when it hits the ground. Okay. Now, a next question is, which one has a higher acceleration? Okay. So if we think about what is causing the ball to accelerate in both cases. So here, as soon as I release the ball from my hand, it begins its motion, and gravity causes it to accelerate down towards the ground. Here, I throw the ball up in the air, and as soon as it has released from my hand, it flies up in the air and then falls back down towards the ground. As it's traveling up, gravity slows it down until it stops, and then gravity speeds it back up. So in both instances, we have gravity being the cause of the acceleration, or what is actually accelerating the ball. And gravity does not change whether you throw something up, down, right, left, any direction. So in this case, we would say that the acceleration should be exactly the same. Now, just to review a little bit about our vectors and scalars, which one travels the farthest distance? Remember, distance is a scalar, so that's the total ground covered. And here, because the throw has to go up and then come back down, we would say that the throw travels the furthest distance. Okay. Now, if we look at the example of a vector, which one has the largest displacement? So in this case, my original position is here, and the final position is at the ground. And again, remember I said we were going to ignore any horizontal motion here. So my original position is at the top of the cliff, and my final position is at the bottom of the cliff. So essentially, their vertical displacements should be exactly the same. Okay? So in the next video, we're going to go ahead and I'm going to give you some numbers, and we're going to use the equations that we've already learned in order to calculate and prove that our predictions are correct.